In this lesson, we will continue our discussion of intermolecular forces. We will be talking about ion dipole force and London dispersion force. And an ion dipole force happens when you have a salt compound. This is, for example, sodium chloride, Na plus Cl minus. And since water is polar, it will pull the ions apart, causing it to dissolve. As you can see here, here's the positive Na plus. And of course, since oxygen is electronegative, it'll be partially negative and it'll point towards the positive ion. Here it is again, sodium ion. Here is the water. Since oxygen is more electronegative, it has a partial negative charge and a partial positive charge here. And therefore, the attraction between them is called an ion dipole force. Okay. London dispersion forces is predominant in substances that are both nonpolar, but it's present in all substances, and let me tell you why. First of all, let me give you an example. Let's look at a nonpolar substance, F2. Okay, so F bonded to another F. F has 7 electrons, so it'll have 14. 2, 4, 6, 8, 10, 12, 14. As you can see, the electrons are evenly dispersed throughout because they both have the same electronegativity. So this substance is unpolarized or nonpolar. You can eventually turn fluorine gas into liquid if you get it really cold. And what you have to do is as follows. So here it is. Here's the F and the electrons. Okay. In order for this to bond with another F2, you have to give the fluorine an instantaneous dipole. Now, what does that mean? If the fluorine sees a substance on the outside, maybe water, a water molecule, or like maybe the glass, okay, it might make the electrons move to one side. So here are the electrons moving to one side. Okay, this is called an instantaneous dipole. They call it that because for a small instant in time, the electrons are on one side. Sometimes they call this temporary dipole. It's not a real dipole, it's just a temporary one. It just happens in a brief moment in time when electrons shift to one side of the substance. Now that you have an instantaneous dipole or a temporary dipole, these electrons will make the electrons on this fluorine to move to the other side. Okay, inducing a dipole here. So inducing means forcing a dipole. So first, you have an unpolarized molecule. For a brief moment in time, you have a temporary dipole causing these electrons to shift to the other side because they're all negative, making this partially negative and this side partially positive, and this side partially negative and this side partially positive. This is a dipole and a dipole. I don't really need you to memorize instantaneous, induced. I just need you to understand that these dipoles just happen in a brief moment in time and they're not a true dipole. They're temporary, okay? That's all I need you to know. Because of that, because of the positive and negative temporary dipoles, you have an attraction which makes this turn into a liquid. Okay, that's what a London dispersion force is. Okay? So, since all substances have electrons, then they will all have dispersion forces because electrons can move. Since all substances have electrons, all substances have dispersion forces. Okay, but Dispersion forces are stronger or predominant in nonpolar substances. For example, here is water. Here's water and here's water, right? And then here's another water molecule. You can tell that water has a dipole, and it can hydrogen bond because the H is attached to O. So this H can hydrogen bond here. So water, the predominant force in water is hydrogen bonding. But it also has dispersion forces. But we don't normally mention that. We just say the predominant force is hydrogen bond. Okay? In this substance, F2, the predominant force is dispersion forces, and there's no dipole-dipole, there's no hydrogen bonding. Okay? So, what do I mean by that? Just remember, if you have something that is polar and another substance that's polar, the predominant force is dipole-dipole. Dipole-dipole. Or if there's hydrogen attached to FO or N, it can hydrogen bond. If it's nonpolar and a nonpolar substance, the predominant force is dispersion or London dispersion forces. Okay? So let's go ahead, and in the future I'm going to tell you how we can use intermolecular forces and how they affect different properties of substances.